Hello students, welcome back to Sir Rasayan. Today I will explain how to determine oxidizing agent or oxidant and reducing agent or reductant. So first we should know what is oxidizing agent or oxidant. Substances which can oxidize others, mind it, oxidize others and reduce themselves are called oxidizing agent. Now we should know what is reducing agent or reductant. With one example I will explain. Okay. Now see, substances which can reduce others and oxidize themselves are called reducing agent or reductant. Now consider this reaction SnCl2 plus FeCl3. We are getting SnCl4 plus FeCl2. SnCl4 plus FeCl2. Now you have to balance it. So here 8 chlorines are there. So 4 and here also you have to make it 2. So like that way you can balance it. Now see, here stannous chloride and ferric chloride are the reactants and stannic chloride and ferrous chloride are the products. Now we will write the oxidation states of tin and iron in both sides. Here it is having +2 oxidation state, here it is having +4. So what is happening for tin? Oxidation is taking place. And iron it is having +3 oxidation state and here it is having +2. So decrement of oxidation state is taking place, therefore it is reduction. So substance which can oxidize others. So FeCl3 means ferric chloride, it is oxidizing SnCl2 to SnCl4. Therefore FeCl3 is oxidant or oxidizing agent and itself it is reducing. So here oxidant is FeCl3 and what is about SnCl2? SnCl2 it is here reductant or reducing agent. So what is reductant or reducing agent? Substances which can reduce others. So SnCl2 is reducing FeCl3 to FeCl2 and itself it is oxidizing. So therefore SnCl2 means stannous chloride is reductant or reducing agent. Clear? Now we will see how to determine oxidant and reductant. The compound in which the central element is in highest oxidation state. How you will understand highest oxidation state of an element? Group number of that element is the highest oxidation state of the element. So the compound in which the central element is in the highest oxidation state, then it will act as only oxidant because it can't increase the oxidation state anymore. Because it can't increase the oxidation state anymore because it is already in highest oxidation state. For example, consider KMnO4. Oxidation state of oxygen here is -2. Each oxygen is having -2. Here potassium it is having +1. Manganese oxidation state will be, for manganese oxidation state is +7. So manganese is group 7A element. So for group 7 highest oxidation state is group number only. So highest oxidation state is +7 and manganese is in +7 here. So it can act as only oxidant. It can oxidize others and itself it will be reduced. Clear? Now see the compound in which the central element is in the lowest oxidation state. How you will determine lowest oxidation state? It will be group number -8. In the lowest oxidation state, then it will act as only reductant. Reductant means it will reduce others but itself oxidize. For example, H2S, hydrogen sulfide. In H2S, sulfur is in -2 oxidation state. Sulfur is group 6b element. So for sulfur, lowest oxidation state will be 6 minus 8 is equal to -2, and highest oxidation state will be its group number, means 6. This is lowest, this is highest oxidation state. And here in this compound, sulfur is in lowest oxidation state. So it can increase only its oxidation state. Itself it will oxidize and it will reduce others. So it will act as only reductant. Now see the compound in which the central element is in the intermediate oxidation state, it can act as reductant as well as oxidant. For example, in sulfur dioxide, what is the oxidation state of sulfur? +4. You know sulfur is group 6 element. It is having lowest oxidation state -2 and highest oxidation state it is having 6 +6. So it is intermediate in intermediate oxidation state. So it can act both as oxidant and reductant, because for sulfur increment of oxidation state and decrement of oxidation state both are possible. Now we will do 1 or 2 questions. Now see the compound that can't act both as oxidizing and reducing agent. So acting both as reducing and oxidizing agent, oxidation state of the element will be intermediate. So now see, this is hydrogen peroxide, this is peroxide. Okay, so here oxygen is having oxidation state -1. Next, H3PO2. If you calculate, oxidation state of phosphorus will be +1. Here for sulfur dioxide, oxidation state is +4. And this is nitric acid for HNO3, oxidation state is +5. So for each element, you can check what is the group number, and then highest and lowest possible oxidation state you can find out. So you will get the answer this one, because here for nitrogen +5 oxidation state is here, and this is the highest. Here nitrogen is in highest oxidation state. So nitric acid can act as oxidizing agent or oxidant only. Others can act both as oxidizing and reducing agent. Clear? Because for oxygen, you know, -2, +1, +2, all are possible. Next question, the compound which can act both as oxidizing as well as reducing agent is, 4 options are there: sulfur dioxide, permanganate ion, perchlorate, dichromate ion. Okay, so for sulfur dioxide, oxidation state is +4. For permanganate, oxidation state is +7. From KMnO4 we are getting MnO4, okay, MnO4 minus. Perchloric acid is HClO4, so perchlorate ion is ClO4 minus. Here oxidation state, if you calculate, it is coming +7. And this is dichromate. Potassium dichromate is K2Cr2O7. This is dichromate ion Cr2O7 2 minus. Each chromium is having oxidation state +6. Now see, for acting both as oxidizing and reducing agent, element should be in intermediate oxidation state. So here chromium, chlorine, manganese all are in highest oxidation state. So for acting both as oxidizing and reducing agent, this is your answer. It is in intermediate state of oxidation. I hope it's clear to you. Thank you for watching.